All right, let's take a look at some other type of graphs when we do end behavior. It says use a graph of this equation to describe its end behavior. Fourth conjecture numerically. And I didn't do that in the last problem. That's just where you plug in like negative infinity for x if you want to go left, or positive infinity for x if you want to go right. Just kind of see what it gives you. But I think it's easier just to look at images rather. So if we have to find end behavior, you're always going to start with this. What happens to y as x approaches the left? Remember, left is symbolized by negative infinity. And you'll also say, what happens to y as x approaches the right? Okay, so what does happen? Let's check that out and find out. On our image here, what happens as the graph goes to the left? Well, it looks like some might say it goes down and to the left, but the truth is it actually approaches an asymptote. There's an asymptote in here at the value y equals 0. There's going to be an asymptote, and this thing will approach. Now, I know it cuts through it horizontally, and sometimes horizontally it'll cross over an asymptote, but this is the asymptote this graph actually approaches. There's also another asymptote here, and there's another asymptote here. Now, so what happens is this graph actually flattens out and approaches that asymptote. So if you needed to find an answer when it says, what happens to y as x approaches the left? Well, you would say this one, it flattens out on this value here. Now, what is that value? It's 0. So what happens to y as x approaches the left? It flattens out at 0. What happens to y as x approaches the right? Well, we look, it also will approach this asymptote. So it'll approach 0. Now, this problem didn't ask for it, but because we're pre-cal, pre-AP, I'm going to include this in here. There's also limits for any type of asymptote. So we have more limits here. If I wanted to do, let me mark these so you can see which one's which. We'll say this is the first limit. Okay, the second limit is over here. Now, there's also more limits. Let's do this one as number 3. Here's how you'd write that. You'd say, what happens to y as x approaches? Now, you see how this is on the value, the x value of 1, but it's on the left side of 1. So you do a 1 with a minus. That would mean the left side of 1. That would be the third limit. So what does happen to y on the left side of 1? Well, our graph goes up to positive infinity. All right, let's try another one. Let's try this one down here. If we did this as the fourth limit, we would say, what happens to y? What happens to y as x approaches 1 from the positive side? Oh, I'm sorry, I put positive 1. This is supposed to be negative 1. Let me correct that. I'm sure you're confused. I'm sorry. So negative 1 from the left side. This would be negative 1 from the right side. What happens as the graph approaches negative 1 from the right side? That's what that symbol there means. Well, this one goes down to negative infinity. Now we have 2 more limits here. We have 5 here, and we'll do this one as number 6. So fifth. We would say, what happens to y as x approaches, let's see here, this is approaching the x value of 2, and it's on the left side, so we put a negative up where the power would go. That would mean the left side of 2. Well, we would say that on the left side of 2, the graph is going down to negative infinity. And then we have the last limit, and that's what happens to y as x approaches 2, but now from the right side. And the answer is on the right side over here, the right side of the value of 2, x of 2, the graph is going up, so you do a positive infinity. That's how you'd find not only this is in behavior, these two, these are left and right side behavior.